Math 100, lesson 7.1, rational expressions and their simplification. All right, so a rational expression, before we get too far here, is just fractions. That's what it means to be a rational expression. It's a fraction expression. And so when we work with these, there will be these things called excluded values from time to time. That is any value that makes the denominator equal 0. And so the way we will talk about the expression is we will say that the rational expression is undefined at these excluded values. Okay, to exclude means you cannot include them. And so it would be undefined at those particular values. So let's see how that can be useful. For the moment, let's just find all numbers for which the expression is undefined. So that's just the first question we're going to work with to make sure we understand what that even means. All right, so let's start with 7x minus 28 over 8x minus 40. So that is a rational expression. It is a fraction expression. Okay, and we're looking for values for which it is undefined, which means where the denominator is equal to 0. So to work this particular problem, we only care about the denominator. We're going to set the denominator equal to 0, solve that. So we don't say x equals 5 is our answer, like that is the value of x. That is the excluded value. So at x equals 5, the expression is undefined. That means it cannot equal x is 5. All right, because that's where it's undefined. Now that is what we were looking for here. But if the direction said solve for x, well, x cannot be 5. It is considered an excluded value. All right, so same directions. Looking for the numbers to make this expression undefined. Okay, so again, we take the denominator. We're looking for what makes it undefined. So we set the denominator equal to 0. Now this is where that whole factoring from chapter 6 is super important, because in order to solve this, you must be able to factor. We're looking for two numbers that multiply to be AC, but add up to be B. A times C is negative 28, and my B value is 3. So those numbers are negative 7, positive 4. So we solve each one for 0, set each one equal to 0 and solve. So I get x is 7 and x is negative 4. Now, these are the places where the expression is undefined. That's not how you spell it. Undefined at x equals 7 and x equals negative 4. It is undefined there. There is a big difference in deciding where it is undefined and solving. They are different questions. Okay, so the next thing that we'll talk about is sometimes our directions will tell us to simplify. Okay, and you will know that you are simplified by doing these two things. First, we're going to factor the numerator and denominator if they will factor. They won't always factor. Okay, that's where we'll start. And then the next thing we'll do is we will divide by any common factors, which is why we factor in the first place, because then we'll divide out any of them that they have in common. Okay, so let's simplify 7x plus 28 over 21x. All right, so my simplify means we're going to factor the numerator and the denominator, if that is possible. Well, you can factor this numerator, can factor out a 7, we get x plus 4 over 21x. Can't factor 21x. Now, I could find the things that multiply to give me 21, which is what I should be thinking in my head. All right, 7 goes into itself once, and 7 goes into 21 3 times. So 1 times the x plus 4 in the numerator gives me x plus 4, and then I've got 3 times x, and that would be simplified. Okay, now a common mistake that people make is they want to say, oh, there's an x in the numerator and an x in the denominator, and you cannot simplify those. And the reason you can't is because of this plus right here. All right, that little plus connects the x to the 4. I like to say that they're married. You can't separate them no matter what. They cannot be broken. All right, so when I look at x is no longer alone. It is x plus 4. It's no longer just x and no longer just 4. It is x plus 4. So you cannot simplify the x over the x. That will not work in this case. All right, let's try another one. All right, so our directions are still simplify. So we are going to factor the numerator and factor the denominator. Our numerator has an x squared in common. When I factor it out, I'm left with x plus minus 1. My denominator has a 7. All right, now in this case, it says divide by any common factors. Well, the numerator has an x minus 1, and so does the denominator. So I can divide by that whole factor, and it gives me a 1 and 1. So my simplified answer would be x squared times that 1 over 7 times 1. So x squared divided by 7. All right, let's try another. All right, again, we're simplifying, so we must factor the numerator and factor the denominator. All right, so in our numerator, we have difference of squares. So that becomes x plus 1 and x minus 1 in my numerator. In my denominator, I have a trinomial. Okay, the top was difference of squares, and the bottom is a trinomial. So I'm looking for two things that multiply to be a times c, and two things that add to be 2. Well, the only solution there is 1 and 1. I prefer faux fractions. I take my a value with the variable, put it over the number I found, a value with the variable over the other number I found. So my factors are x plus 1 and x plus 1. You may certainly continue to do factor by grouping. Make sure you do it all to the side and then put your factors back in the fraction. All right. So in my numerator, I have x plus 1 times x minus 1. My denominator, I have x plus 1 times x plus 1. So I can divide out common factors. Well, here's an x plus 1 divided by an x plus 1. You can't just mark all of them out. All right, we can only divide by common factors. So my solution here is x minus 1 in the numerator and x plus 1 in my denominator. Remember, you cannot factor out, you cannot mark out or cancel out those x's because of the minus in the numerator and the plus in the denominator. They are bound together. They do not stand alone. let's try one that looks a little bit different. Okay, now this particular problem is a little tricky. They look really close to the same, but notice the numerator and denominator are backwards from each other. If I made them go the same direction, like if I put x in the front on both of them, then this would say negative x plus 3 in the numerator, and if I just leave the denominator alone. So all I did here was rewrite the numerator. I didn't change anything other than the order that it was written in. Okay, negative x plus 3. Now, they're still not the same. It's a little more obvious to see that they are not the same. So in a problem like this, where they are really, really close, but their signs are different, here's what we're going to do. We are going to factor out negative 1. And it doesn't matter if you do it from the numerator or denominator. We're just going to do it from the numerator because that's the one that I've been working with. Okay, so if I factor negative 1 out of the numerator, that leaves me with positive x minus 3. Not changing my denominator. Now we have a common factor in the numerator and the denominator. So those divide out to give me 1. So I'm left with negative 1 in my numerator divided by positive 1, which is negative 1, would be my solution. Okay, we're still simplifying. All right, so our first step on simplifying is factor the numerator and factor the denominator. Okay, so my numerator is difference of squares. So we use our little rule about difference of squares. My denominator, they have a 4 in common, so I factor out a 4. Okay, now when I look at these two factors, the one in the numerator and the one in the denominator, they're really, really close, but they're backwards from each other. Okay, so this is where I have to do the factor out a negative 1. Remember, I told you it doesn't matter if you do it in the numerator or the denominator. I'm going to do it in the denominator this time. Okay, so my numerator is not going to change. It is going to stay just like it is. When I factor out a negative 1 in the denominator, it gets multiplied by that 4 that's sitting out there. So it becomes negative 4. And then I can turn this around to say 3x minus 7. Because it makes the 3 positive and it makes the 7 negative. Now I have common factors that can divide out. And my solution would be 3x plus 7 in my numerator divided by negative 4 in my denominator. Now, occasionally my math lab does not like that negative to go in the denominator, so occasionally it does give you a little error message there. If I wrote negative in front of the fraction, it means exactly the same thing as if the negative is just in the denominator. Okay, not on the negative 3, in front of the entire fraction. Those two say the same thing. Okay, let's try one more. All right, so factor the numerator and the denominator if possible. Well, our denominator will not factor. Okay, my numerator will. That is difference of cubes. So I use my little rule about difference of cubes. So you may have to pull that out to look at that rule. And then I noticed that this 2 minus x in the denominator and this x minus 2 in the numerator are really close, but they're backwards from each other. So this is where I do the factoring out -1, and I'm going to do it on the bottom, the denominator. I'm going to factor out -1 right here. So my numerator will not change. And my denominator, I factor out a -1, and then I'm able to write this the other direction because it does change the signs. It makes that a positive x and a -2. Now I have common factors that will divide out. And so my solution is x squared plus 2x plus 4 in the numerator, divided by -1. Now, my math lab is going to tell you that that is not simplified because it's not. It's not simplified. Okay, you can't leave a -1 in the denominator because you can actually divide everything by -1. And so if I divide positive x squared by -1, I get negative x squared. Positive 2x divided by -1, I get -2x. And positive 4 divided by -1, I get -4. So this is the simplified solution to this problem. So make sure that your answers are completely simplified, or you will be frustrated. And that is all for section 7.1.